have a clear liquids lab for grade 5 science. We started with 4 clear liquids. They might look the same, but in fact one has dish soap, one has rubbing alcohol, one has salt water, and one has tap water. In this lab we'll learn how we can tell the difference between them. Each of these clear liquids will have properties of its own, the way that they would react in certain situations. So we're going to start by testing first what these liquids look like. I've put our cups on a brown paper towel just so we can see a little contrast. Do you see anything that is noteworthy? Well, right off the bat, I noticed that 2 of these liquids are quite clear and 2 are a little bit cloudy. So the 2 that are quite clear are the water, looks very clear, and the alcohol. The salt water and the soap look a little bit cloudy. So I need to write that into my table right here. We now can start with some of the tests. We're going to start with how these liquids react when placed on a plastic bag. So here we are. I've used my droppers for my water, salt water, alcohol, and soap, and I put 2 drops of each liquid onto my plastic bag. And here's what I found. There's the water and the salt water. So you can see those 2 drops. They both look like they're still almost round. They have a nice rounded shape. You know, it's a perfect circle. And the top is kind of a bubble-ish looking thing. So you can't really tell the difference between water and salt water. Now when you move over to the alcohol spread out all over the place. Oops, there we go. There's the alcohol. It's not a rounded shape. You can see it's kind of got a funny shape to it. Might be a little hard with the glare. And it certainly doesn't form a bubble on the top like the water and the salt water did. It's spread out. And our soap kind of seems to be halfway between the alcohol and the waters. It still maintains a bit of a rounded shape, but it isn't as round as it could be. Okay, so there's the salt water and water again, the alcohol that spread out all over the bag, and the soap that's kind of halfway. So what I did is over on my table, I wrote that down. I put that the plastic bag test, the water and salt water stayed in drop form. There's the water, there's the salt water. The rubbing alcohol spreads out, and the soap, I kind of put it's some spreading, but still in drop form. It isn't as round as the waters, but it isn't as spread out as the rubbing alcohol. The wax paper test is next. So all 4 liquids get put onto the wax paper. I just completed the wax paper test, and it was very similar to the plastic bag test, which I've moved to the back there. Okay, there's that water droplet again. Looks very similar. It stayed in droplet form, and actually I put 2 drops in, and the first time when I missed, 1 drop landed here, 1 drop landed here, and they just came right together and formed this bigger drop here. It was quite neat to see. The salt water looks exactly the same as the water. Okay. The alcohol, it's spread out, it's flatter, it's not quite as bubble-ish as the waters, but it still maintains a rounded edge. So that's a little bit different than the plastic bag. Remember in the plastic bag it kind of spread out and didn't have a rounded shape? This one still maintains a roundish shape, although it's flattened. And our soap, again, a little bit flattened. It didn't maintain a rounded shape at all. In fact, it kind of spread out into a unique shape. So I've written all of that information down on my table right there. Okay.
We now did 2 tests together using brown paper towel and pink construction paper. This is what happened when 1 drop of water was put on each type of those papers.
Okay, so I thought I'd bring you back before I tested everything because I tested just the water by itself. And you can see here, this is after, a couple minutes. I put the drop on that brown paper towel, and you can see I put immediately, this is what I saw. I saw that the water droplets spread out immediately into a large circle. And this is basically what it looked like right away. So after 1 minute, I haven't filled this in yet, but after 1 minute, this is going to look much the same as it did at the very beginning. So water spreads out right away. On the construction paper test, this is the end result. It looks pretty much the same. You've got kind of a rounded shape on the brown paper towel, and you've got another rounded shape here. So they ended up looking the same. However, on the construction paper, it stayed in drop form, but spread out from there. So maybe I'll just show you this really quickly. I'll do another drop right beside. 1 drop of water. Do you see how the bubble, the drop itself, disappeared and it spreads out? Here is the construction paper. 1 drop. Okay, it stays in drop form. But you can see that there's that spreading out underneath. That circle under the drop is getting bigger. And after about a minute, that drop will be gone. So I need to finish filling in this chart, and I wonder what salt water is going to look like.
So we had a neat result for water. So how does salt water look? Does it do the same thing that water does?
It's been about a minute when we put the droplet of water on, and the salt water on the brown paper towel, again, looks very similar to when it first started. However, if you can see, as the water evaporates, do you see the salt is left behind? There's some white crystals kind of right in there. So the water is left behind and you're left with a white residue. So I need to write that down on my form, on my sheet, because just pure water, tap water, there are no crystals. There's nothing left after the water evaporates. So that's something that's a little bit different. Down here with salt water, wow, it's eventually getting bigger. That drop is still there, but the spread out section has gotten bigger over the last few minutes. Remember this one? It had pretty much spread out. By a minute was done, there was no drop left. This one's taking a lot longer to spread out on the construction paper. So I need to fill that in on my sheet, right over here.
Now we're going to look at rubbing alcohol. How does it react on the brown paper towel and the construction paper?
Time to test our alcohol samples on the brown paper towel and on the construction paper. So here we go, 1 drop of alcohol. Wow, that's spread out pretty fast. Look at how fast that is. Okay, there's no droplet at all. It didn't have time to have that droplet form. It just spread out and away they went. Let's see if it does the same thing on the construction paper. 1 drop. Yep, there were no droplets left on the surface. Construction paper seems to keep the spreading out smaller. If you compare the sizes of the spread out areas, what I'm seeing right now is that brown paper towel lets the items spread out a little bit further. So that's a difference that you might be able to take into account. You know, when I look at this one, I'm thinking this one almost looks like it's dry. It's almost at the same dryness as salt water, and it's been about 5 minutes or so. You know what? I'll fill in my chart with the immediate reactions, and I'll take a look after, and I'll see if that's something that alcohol might do. Maybe it dries faster.
We have one last test for soap on our construction paper and our brown paper towel.
All right, so I filled in my chart here for what happened with the rubbing alcohol. It spread out quickly and no drops were able to form. And the same thing down here for my, on the pink construction paper, it spread out quickly, no drops formed. And now I've also noted that at the end, this has been about 2-3 minutes, you can't even tell there was a droplet of alcohol on this brown paper towel, whereas you can still see how the water has affected. It's still damp. The alcohol, it's gone, it's evaporated. Same thing on the pink paper towel. You can still see a slight discoloration right there, but nothing like the water and salt water. Oh, and this bubble's all gone out as well, so it did eventually disappear. But that might be a way to tell the difference between the liquids, is if you put a drop of unknown liquids and one evaporates a lot quicker than the other, you might have alcohol as one of the liquids. Okay, time for our last drop here. Let's get some soap in our dropper. And let's see what happens. Spreads out very quickly. Again, there's no bubble that was left on the surface. It just all soaked into the towel and spread out. It reminded me a lot of alcohol. And let's see what happens down here. All right, same thing. It spreads out very quickly. No drop left on the surface. It just all soaked right in and started to spread out. I'm going to write that down. And you know what? These two, soap and alcohol, seem to operate the same way. When with brown paper towel and with the construction paper, there's no droplets formed on the surface, and they just go straight into the paper and spread out. I wonder if soap will evaporate as quickly as alcohol does. I'm going to write down my observations, and maybe what I'll do is I'll do another little small test here. I'll put a soap and an alcohol side by side, and I'll put a soap and an alcohol side by side, and I'll see if they evaporate at the same rate. So I'll check that out and I'll get back to you.
The last test was to see how a drop of the liquid would run down the side of a plastic cup.
All right, I've changed my camera angle a little bit so you can see what's happening. Here I've got my white plastic cup, and I'll just reach in and I'll get a drop of water first. And all I'm going to do is I'm going to see how that water droplet runs down the glass. Does it go quickly? Does it stay in a drop? Well, let's just try it. So I'm going to put my drop. I hope you can see this. Okay, so it stays in drop form. I'm going to tip it up a little bit. Maybe I'll put another drop and 2 drops. Okay. So it all runs together. Okay. I'm going to empty and dry out my form. So that the water just stayed in a bead. And you know what? That's what we've seen with the other stuff that we've done. Now, water seems to stay in a drop form. Let's take a look at what happens. I've turned the cup a little bit so that our salt water doesn't have the same path. Let's see if we do 2 drops of salt water. Kind of stays in a bead, doesn't it? Stays together as it gets to the bottom. If you're not really sure, we'll compare that with the water again. I'm tipping my cup a little bit. Salt water seemed to be a little bit more spread out, but okay. I'm going to dump this out actually. There we go. I'm going to turn my cup a little bit more. You can see the tracks of where the water ran here. So I'm going to start on a clean side, do a couple drops of alcohol, and let's see what happens with the alcohol on the run test. Well, it kind of spreads all over the place. It doesn't stay in a drop form. It spreads all over. And finally, our soap test. Oh my goodness. It didn't stay in drop form either. It spread out and away it went. Okay, so that was the run test down here. So I'm going to fill in my chart, and when I come back I'll have an unknown liquid and we can test it and compare what we've seen and what we've done.
Time for our unknown liquid. What do you think it's going to be? How will its properties compare to the properties of the four liquids we know?
There it is. There's our unknown liquid. I've found it. I need to know what this unknown liquid is. And if I look at the color, it's a little bit cloudy. So I would mark on my table that I would mark it was cloudy. And right off the bat, I'm seeing that I'm already assuming it's either going to be soap or it's going to be salt water, just based on what I've seen here. Now, we shouldn't go with what we see all the time. We need to check again and again. So let's do our other test. I'm just going to write in cloudy. So the plastic bag test. Bring that back. Oh wow, look at this. I mean, we did this test a while ago, and you can still see the results, although the alcohol one seems to have evaporated again. Soap is still kind of in a spread out way, but salt water and water are still nice and beaded up. So what would I assume? If my hypothesis, just by doing a visual check on this slightly cloudy mixture or solution, I would think it's salt water or it's soap. So what should I see on this plastic bag? Well, I should either see the salt water beading up, or I should see the soap that's kind of still beaded up, but it's not in a droplet form. So let's see which one. I'm going to put my drop right up here. Well, what do you think? That's a pretty rounded drop, isn't it? When I compare this drop with what I see here or what I see here, I'm thinking this is salt water. It's acting the exact same way on the plastic bag. Okay, so I would fill in this next line here with what salt water looks like. It stays in drop form. But I'm going to go ahead and complete the rest of our tests. Fill up my eyedropper one more time. Salt water on the brown paper towel. Remember how it left some crystals behind? Okay, spreads out quickly, has a bit of a, maybe a little bit of a drop form in there. But not exactly. It's that drop, it's gone. So it spreads out really quickly. Okay. Here I'm going to put it right here because I think it's salt water, so I may as well test it right next to the other one. Stays in droplet form, but spreads out around the outside. And that's what we're supposed to see, right? With this one, do you remember what happened with the brown paper towel? Is that the water all evaporated and then the crystals were left. So if we're right, when this water's all gone, there should be crystals left behind. So we'll check on that. This one eventually all evaporated, or it all spread out, sorry. But it took a long time for the salt water bubble to evaporate. And way over here on the wax paper, again, this looked much like the paper towel. So a drop here should stay nice and round. Yeah. The soap drop is still there, but it's not round. It's not a bubble type form. So I would say that our unknown solution, based on what it looks like, how it acts on a plastic bag, how it acts on brown paper towel, how it acts here and here. I would guess our mystery solution is salt water. So I hope that you had fun learning about some of the ways we can tell some of these unknown liquids apart and how we can use properties to help us.